Welcome everyone to Big Kaiser. We are so happy everyone could attend today. We have a great morning in store for everyone, so I hope you got your coffee and you're ready. I would like to start in with our first session today and introduce a good friend of mine, Wade Anderson from CNC. And Wade has traveled to Chicago.
Yep.
Thank you for coming. It's great to see you here. I didn't know if we'd ever get to see people face to face again, but I'm really appreciative that you were able to make the trip, come up here and join us today. And Wade is Director of Partners and Think, amongst a couple other things that you do, product manager or product specialist for all the different products you offer at Akuma. And we've known each other for several years now, and
Right.
we always have a great conversation, which was part of the reason that I thought of this little topic about some of the things that customers who are looking at new equipment or used equipment should really think about before they pull the trigger. You know, and I
Sure.
know the sales guys would all say, hey, make sure they don't think too much because they might change their mind. But, you know, from our side, the technical side, we want to make sure they get the right stuff.
Right.
So the topic is about 6 considerations, but before I get into those 6, let's talk a little bit about the difference between new and used equipment, because the used market could be a really good deal, but what are some of the things that you think you want to be really careful about on the used market?
So that's a great topic. To me, you first have to start with the why. There's the old Japanese saying of 5 whys, you get to the root of any problem. So I always look at why is the machine on the market. There's a lot of really good videos out. You can watch YouTube videos of machines getting wrecked, of mishaps happening. How do you know when you're looking at 3 or 4 used machines, which one of those 3 or 4 machines was the one that was in that YouTube video? So finding out the why is the machine on the market? Did the owner upgrade technology? So you're buying a machine that doesn't have the levels of technology that maybe you need. Was there a problem with the machine that got band-aided and it was put on the market? Or did the shop owner did they get into the market, they overspent, got too much equipment, went bankrupt, had a financial issue, and it hit the market that way?
Yeah.
So there's definitely opportunities. Anytime we go through a recession, anytime the economy has a correction or retracts a little bit, there's people that are overextended and some really nice equipment gets put out on the market, but you really have to do some due diligence to understand what are you getting. And then, does the machine have a warranty? What type of warranty are you getting with the machine? And how do you know that the money that you're saving on the used equipment, are you saving enough to cover if a drive goes out? If there was damage in the spindle that you didn't catch or didn't know about, is the money that you're saving going to offset if you have to make some corrections to that machine down the road? So those are some initial considerations that I always look at.
So I guess you got to be pretty astute, know what you're looking for, go see the equipment,
Yeah.
and just like you're checking out a used car, you want to know all the little behind the doors looks that you can guarantee you're not getting a lemon.
So you touch on a really good point there. When I typically buy used vehicles, partly from a financial aspect, but 2, I'm a gearhead. I went to school to be a mechanic. I've got some just interest in working on vehicles. So I don't mind if I buy a vehicle and an alternator goes out, I have some issues. 90% of what goes wrong, I build Jeeps, so 90% of what goes wrong, I can probably wrench on it and fix it and do it myself.
Yeah.
So as a shop owner, you need to judge that. Do you have the talent or the skill set within your organization to change out a spindle, to fix a ball screw, things of that nature? If you do, hey, that might be a great way to go if you've got the time, money, interest into doing that. If not, if you're bringing in third-party people to do that work, again, there's a financial consideration that's got to go into that.
And then I guess you got all the other underlying costs of rigging the machines out and then transferring it to your shop and all these things. So financing. So yeah, I guess you just buyer beware in that situation, right?
Sure.
Okay. Yep. So we have 6 considerations for buying equipment. And many times as a tooling company, we get confronted with new equipment that's been into the shop, and the programmers are starting to analyze what types of tools that they want to put on the machine, and they find, well, the capital guy bought this, but I'm forced to use that, and this disconnect sometimes hurts productivity, and that's what we're going to try to talk a little bit about is alignment. And the first thing is, if you're looking at equipment, how does it align with what you currently use in your shop? And what are some of those factors that you would want to look at? Controls and maintenance, what do you talk about there?
One thing I always like to look at is the culture of the company. So anytime you bring in a new piece of equipment, any change creates a little bit of chaos, right? So you've got the status quo that people are used to, and then you're bringing in something new. Do you have a culture within your company that's willing to adapt new technology and sink their teeth into it? So that's one big consideration I always like to look at is when you're bringing in a new piece of equipment, do you have the culture within your team that wants to embrace new technology and step up to a higher level of technology and ways of doing things? So that's one consideration to start with. And then the building, do you have the right foundation? Do you have door width? There's a lot of times we get brought into projects and the type of machine that fits what the customer needs, the 12-foot garage door that he's got on the shop's not big enough to get the machine through.
Well, it just became a 14-foot door now.
Right, or we're stripping sheet metal off machines and trying to condense it to make it fit. So things like that are also important considerations to undertake.
So if you go into a shop that's, and I don't say, one shop only has this brand of equipment and they'll never change, what do those kind of shops need to keep looking at around them that they're not tied into saying, okay, we won't buy any other brand of equipment because we like their control and we like their service? Does that help or hurt shops like that?
So that's a good question.
I know it is.
It's interesting. You've got laws of physics, you also have laws of economics, and there's trade-offs to everything, as part of economics. So there's benefits of having a team that you stick with, that you're comfortable with, and you get good service and support and things of that nature. The trade-off is, as new technologies come out, if the people that you're aligned with aren't bringing out some of these new technologies to the market quick enough, you could be missing the boat on enhancements and increased productivity. So you always have to be constantly aware of what's taking place in the marketplace. Is there new technologies coming out? But you also want to hedge. You don't want to be the first guy necessarily into some of those new things, because if you put a lot of time, money, and efforts into it, then it doesn't pan out, then you're backtracking, and that can cause other externalities that you have to deal with. But being able to have a pulse on what's taking place in the market, what the new technologies are, but then any leader, a leader in general means you have to have vision. So any leader, whether you are a shop leader or you're the owner and you're leading the company, you have to have foresight and vision on where you're trying to go. What do you need to accomplish right now? But then what does 5 years down the road, what does 10 years down the road look like? And technology changes so fast. Now, talking about 5 years, that's like an eternity away. But you have to have that vision on where you're trying to go, and then we got to make sure we don't handicap you on getting there. So you don't want to get backed into a piece of technology that's not going to allow you to grow in the future of where you want to go.
And we see this sometimes on the tooling side. We go into a shop and I call them cat houses.
Yeah.
And not in a bad way, but they strictly only want to use the Caterpillar V-flange tool shank, 40 taper or 50 taper. And we know that there's always sometimes a little bit better way of doing it. So a company that might want to get into micro machining, for example, they're kind of stuck on CAT, but actually CAT doesn't lend itself to that high speed. So they almost have to be forced into maybe a smaller HSK taper tool, and they're like, what is this thing and where does it come from and how do we get it? And it can be changed. Change is sometimes disruptive, but it is necessary in situations like that. So yeah, we have to always go with the technology and follow what's necessary to do it the right way. Well, thanks for that. And the second topic would be intended use. We try to define, as every shop, how do we want to use it? Is it going to be a new project, or is it general purpose or added capacity? How do you align those factors? What's the most important to the least important about?
So those are great conversations to have with people. You need to understand, what is the customer trying to do? What is a shop owner trying to do with the equipment? Is he taking on takeover work, so the process is kind of already developed and he's just continuing on that process? Or is he adding capacity to the shop? and he doesn't know what's going to come in the door. He wants to have a process that's flexible enough to take on anything. So materials is a huge consideration. Are you cutting aluminum where you need horsepower and high speeds? Are you cutting titanium where I need torque and grunt strength to be able to cut it? Those are two different considerations. So we always try to look at what type of work. Most job shops tend to fall into some type of a market. You know, they're a job shop, but they're targeted towards aerospace or automotive, or you have the OEMs, so you know what their products are going to be. So we always want to look at the material, what are they cutting, and then what is their philosophy on removing metal? Are you fast, high speed, dynamic machining, high feed mills? Are you the type of guy, I tend to be more of an old school machinist. I like deep, heavy grunt work, depth of cut. You know, there's trade-offs again. Laws of economics, there's trade-offs to it. So what is their machining philosophy? How do they want to approach removing metal? And then now let's talk about which type of platform we need to go in. You start peeling the onion on spindles. Do you need an integral spindle? Do you need a geared head spindle? Boxway versus linear way. There's a lot of different considerations. And then tooling, what type of tool holders? I'd push that back to you. What do you look at when you're talking materials? How do you decipher, are we going with a Cat 40, or are we going with a Cat 50? Are we doing an HSK A100? How do you delineate that?
Well, we're pretty much dictated by what the machine is coming equipped with. So we try to work around that. And sometimes we're pressed, and certainly Big Plus will give us a little advantage that maybe the customer hadn't intended they would have. And we can discover with them, and we talk with them and say, you know, your machine is a Big Plus equipped spindle, so we can take some of those heavier cuts that maybe you weren't expecting. And as far as, you know, when we look at HSK or Big Plus or BT, there are certain advantages to each one. And certainly with, you know, an HSK 100 horizontal boring mill, we have everything that they could probably want to use for heavy cutting as well as fine finishing. But where it gets a little bit fuzzy, I guess, is when you get into the smaller taper sizes and people are looking at, well, I want to do a little bit more roughing on this smaller machine. And like this tool right here, you can see that's designed for a small taper. You got to really get careful about projection and length, because that can really hurt you on those small spindles.
Your bending moment.
They kill you.
Right.
And it usually comes back to the tool, and that's the part that we are specialists at, is making it as short as possible to get the best cutting efficiency. So we try to look at those factors, and you know, a lot of people like versatility. They like to be able to use shrink fit, so they put straight shanks into them, and that gives added flexibility, of course. So that's working into our favor sometimes too, but I think the customers have to select what's the right tool holder for the application, and try not to do general purpose. This is how we always did it in the past, and honestly, doing it the way we did it in the past is usually a side lock end mill holder, and we don't like those. We sell them, we just don't really like them because they don't make the machine or the tools look much better than they were before.
I love anytime I hear somebody say, well, we do it this way because that's the way we've always done it. I love to hear that, because that perks my ears up to know, okay, there's opportunities here. We can make it better. Because if you've been doing things the way you've always done it, I promise you technology is passing by right as you're speaking, and there's better ways that we can peel the onion on that and come up with a new process that's going to make you more efficient.
And we know that doing something differently probably costs more. Right? So if you're used to paying certain amounts for things, and that's how you always did it, of course you know what you're going to pay for. New technology does cost a little bit more, but usually you're going to see the benefits. And typically, 1 year after we introduce a new technology, a new tool holding system or whatever to a customer, there's no regrets. In fact, they're very appreciative, and a couple times they'll say, wish we'd have done this years ago.
Right.
You know?
So it's the old adage, a mentor of mine once told me, pay me now or pay me later.
Right.
So, you know, you got to look at the financial return on it, and then understand, when I make this change, is that going to improve my financial outlook on the process and the parts that I'm making? So that's something that has to be looked at when you're looking at new technologies.
Right. So let's go right over into the workpiece size and types.
Okay.
New job, I got to have something tomorrow. Just give me a machine at least this
Delivery.
or bigger. I don't care if it's bigger, I can work with that.
Yep.
But what is some of the issues when you think about that mentality? Just give me whatever you got and I'll make it work.
Right. Well, one, you settle sometimes. There's times we're fortunate enough, we bring in a lot of machines into inventory. Most builders do. I'm not just speaking for Okuma. All your top machine tool builders, we inventory and we stock machines in the U.S. at different warehousing locations. So a lot of times we have a lot of inventory that we can pull from, and we're fortunate enough that we've got the right mix that will match what the customer needs. Other times though, unfortunately, we may not have the exact specification that a customer wants. So he says, well, just get me the closest thing you can that can be delivered quickly. Well, there, you're trading off, right? There's going to be some features or perhaps optional content, things of that nature that machine doesn't have. Maybe you're settling for a Cat 40 when you really wanted a Cat 50. One of the things that is playing a deeper role today is automation. So if you look at automation, you start building a process for an automated cell, and then you need to incorporate another machine into it. Does the pallet change? If you're talking like a horizontal or a 5-axis machine where you're moving pallets in and out, are the cones the same? The cone spacing on the pallets, can you interface that without additional heartburn with adding a different flavor
after
machine
the fact,
into it?
it's going to be pretty hard to change that up to be the same stuff and probably a lot more expensive.
Look at FMS systems for an example. Can that FMS system and the machine that you're plugging into it, can it handle a mix of different types of pallets? So those are considerations that you got to think of as well.
Yeah, we see it too on a new piece of equipment is installed, and they'll bring in the old fixtures, tombstone or whatever, and there's we just need to upgrade the equipment. We want to put it on this new piece of equipment, but the strokes are different. And all of a sudden they get it up there, and the first thing they put a tool in there, and it's like, we've been running this for 5 years or 10 years in production the old way, but now all of a sudden they alarm the machine, we can't get to the part.
Yeah.
And so what's the first thing they do is they say, get longer tool holders. That's the easy fix, right? So we usually get some of those panic buys, say we need some 8-inch gauge length Cat 50s, shell mill holders. It's physics, and the longer that gets, the more the bending moments increase, the less cuts you can take, and that's the sacrifices we see.
Yeah.
And there's no way around that. But I would like to say, maybe instead of panic buy, do you have a little time to maybe look at that work holding? Can you refixture it, get it to the center of the pallet, maybe raise it up? That's another issue we always see. They're too close to the table and they can't get the spindle over it, and it has to stop. That's those dead zones for the horizontal machining centers. They can be cumbersome. A lot of people don't look at them. They're always overlooked. That's the distance from the center of the pallet that the spindle Z can get to.
Right.
And if you don't design your work holding with that in mind, you can make some really long tools that you didn't intend for.
Yeah. And we see that in 5-axis machines as well. You can look at a part and you look at the working envelope of the machine, and on paper it looks like part A fits machine B, until you start swinging this part up and you're trying to get reach, and all of a sudden your travels that on paper look like you were great, you're either too short or too long.
Yeah, those trunnions and
it takes
whatnot.
a lot of forethought to work through and make sure you've got the reach needed and the clearance to work your way around some of these more higher tech parts with the more increased geometries on it.
So I guess going the other way, if you can find a machine that's bigger than what you need, has the bigger envelope, has the strokes and the work pieces and all that'll fit on there. The downside, I guess, would probably be that you're going to probably sacrifice spindle speed or rapid rates or something like that, right?
Right. So again, you've got trade-offs. Now, I'm typically a fan of, especially we're talking horizontals, things of that nature. When in doubt, I like to go bigger because a lot of times I can get a lot more parts on a tombstone or on a pallet. On a 5-axis machine, I might do some more creative fixturing, get more progressive fixturing, things of that nature if I go larger. But you get into reach issues. In turning, especially as your diameter changes, a lot of times your RPMs are sacrificed. So you go to a large diameter lathe, your RPMs are slower, Well, if you got to make a really small part, you don't have enough surface footage to be able to make the cuts that you need.
Correct.
So those are things that's got to be weighed out and determined whether or not what's your family of part size look like, and will you be able to hit the surface footage that you need to make the cuts that you need.
Yeah, and you know, we have ways around that on the milling side. If a customer has micro machining that they wanted to do on a 50 taper machine, there are attachments that we can put onto a standard machine, like an air spindle or a geared drive spindle speeder.
So what kind of RPMs do you get out of a speeder head like that?
So the air spindles are anywhere from 50,000 to 80,000 RPM, but the torque is very low. So we have some customers that are doing extremely large space vessel components, and they got some really small tools, but they need it on a 50 taper machine, of course, and that's only a 5 or 8,000 RPM spindle. So trying to put a 60,000 cutter on these machines just wears them out. Just flat wears them out because they're running at such high speed. And that's a great application for an air-driven spindle because you're never rotating the spindle anymore. It just stays stagnant and moves over with the air spindle. So it's a great application for that.
So it's not the fit for everything, but it's the right tool for the right application.
Absolutely.
Yep.
And you know, a lot of times though, we'll find that they don't want to use 60,000 cutters. They're like, hey, it worked so good there. Why not use an 1/8 inch or a 1/4 inch or 3/16 on bigger cutters? And you know, the torque's just not there on some of these products. You got to get into geared systems. Once you get over 90 or 100 thousandths in diameter, it's just not there.
Okay.
So the other side, you know, we can't, if it's too small, we really can't do much other than amp it up a little bit with some big plus technology or something like that to get the reaches a little bit more rigid that they would want. But certainly bigger, we have ways that we can cope with that. Tooling solutions, you know, we have virtually everything you could need, from collet chucks to hold the smallest to the largest things you want, and beefy cutters, face mill, everything's there.
And speed run out is a major concern, so you got to have quality holders to make sure you've got the run out that you need to be able to handle some of these smaller
that's
cutters.
A great point, Wade, because we always talk about static run out, which is when service is checking out a spindle. They're usually putting a test bar in it, and they're checking how, you know, at a very slow speed, how's the run out. No, it's right there. But the dynamic run out is what kills. Because that's the part that you don't see when you ramp up a machine to say 12,000 or 20,000 RPM. What is it doing as a spindle system? It might be moving outside of its center. And that could be as much as 0.5 to 1,000th of an inch. So some of these machines don't have that built into them, even though they're rated for that, to run micro machine cutting all the time. And that, even though it's a 20,000 RPM machine, would be a viable option for an air spindle, you know, because it just isn't good for that machine to run at so high speeds. And that kind of gets you into the areas of, do we need to balance our tool holders, or can we take the stock holders off the shelf in those sense? So
where do you make the determination on when do you need a balanced tool holder versus when you can just take a stock one off the shelf?
Yeah, that's a slippery one to answer, but generally speaking, I rate that on a 40 taper with our products. If it's a quality hydraulic chuck or collet chuck or something that I know is designed for high speed, up to 12,000 RPM does not need any additional balancing. And for short time, you could run them up to 20,000 RPM. But if I got to look at the size of the collet system, right? I don't want to try to say that with a milling chuck that's got 1 1/4 inch capacity, you can run that to 20,000 RPM. That's probably not a reasonable thing to ask for. But on a 50 taper, we bring that down to about 8,000 RPM as a standard. Over 8,000, and your intentions of running over 10 to 15,000 RPM on a 50 taper or HSK 100, we usually recommend maybe you want to make some balancing, especially if the cutters are not repeatable.
Okay. From my perspective as a machinist and a machine tool guy, I want the least amount of vibration possible. So the one thing I'm saying most, generally speaking, most of our cutters are carbide, some sort of carbide. The substrate and the binding materials that's holding this carbide insert together doesn't like vibration.
Not at all.
Harmonics will destroy your cutting edge. So depending on the type of cuts that you're doing and the type of material that you're cutting, how long that cutting edge a lot of times can be the product of harmonics in the machine tool. So balance for me is very important, along with the entire system as a whole, to make sure that we've got a machine and a cutting process that gives us enough damping characteristics so that we're not putting harmonics into that carbide and losing our cutting edge prematurely.
Well, off camera, I would recommend you and your AEs take a look at the new balance standard, ISO 16084, and it looks at some of that
Nice.
technology. You know, why do we balance a roughing end mill to such a tight tolerance when we look at the cutting forces involved?
Right.
And it puts that into the equations and gives you a different balance compared to a fine finishing tool.
Very nice.
It's an interesting standard.
So you know all these standards much more than I do. I couldn't rattle that number off.
Well, that's our business. ISO standards, of course, everything's controlled here, so we have to make sure we make everything to the most current standard. So that's interesting. And, you know, a tool like this, we would probably want to say, you might want to balance that.
Yeah.
But that's
because of the projection.
Yeah, it's an example of something we don't like to see. You know, when people start building modular systems, trying to overcome reach issues to get into places that, for whatever reason, they can't. But that's where angle heads sometimes are a great option too, to get at these secondary features that without making a 12-inch or 20-inch long tool, an angle head might be a solution.
Yeah.
Yeah.
Shorten it up, be able to come at it from a different perspective.
Yeah, a lot of people don't think I got a 5-axis machine, I should never use an angle head, or even a multi-axis mill turn. We actually sell a lot of angle heads on mill turn centers because there are just places that that spindle cannot get to.
Right.
And features that you want to do while it's still on the machine, and the angle head does it.
Yep.
Cool.
So a quick question on your angle heads, what all tapers can you do on an angle head like that?
We can make angle heads from 30 taper up to HSK 125.
Okay.
And everything in between.
Basically the primary range of everything a machine tool is going to
Basically
bring
every
out.
standard machine tool, yes, we have something that we can put. Most commonly it's Cat 40, Cat 50, and HSK 63.
Right.
But we'll do Capto spindles. The tough part of that is the stop block, the way that
Where the stop block goes on the spindle?
how we mount that on there. And as part of the process of looking at buying a machine, I always encourage customers, look at and make sure that the machine tool company can support auxiliary systems like an angle head.
Sure.
Because they have the details on where the stop block needs to go and what its configuration needs to look like. If you try to do that after the machine is purchased, it's a little bit more difficult.
Right. And most machine builders have multiple spindle options for any given machine. So it's also important to know, you might, for us, our horizontal, say a MA600, that's a 600 millimeter pallet size machine. We have 4 or 5 different spindle options that are very common on that platform. So a customer may buy a 12,000 RPM MA600 and then buy a MA600 with a 6K 1,000 Newton meter spindle. Well, those are 2 different spindles. Even though the machine is still an MA600, where that stop block goes, what the face of that spindle looks like is different between the two. So you got to make sure you're also getting the right spindle for that. Most of ours is in the manual. We have tech info manuals that provides that type of information, but that's a really good consideration for any machine tool that you're getting. Do you have that type of information readily available?
Well, let's go to that topic about workpiece sizes and types and materials and spindle torque. I think we had an interesting conversation last night about this, and you know, most machinists think of power in terms of horsepower.
Right.
Okay, what's that machine rated for? And they always think horsepower. What do you think they should really be
Torque curve.
looking at?
90% of the work that comes across our desk, we're talking about the RPMs that are not at the max RPM where you're hitting your horsepower curve. Typically, you're in the RPM range where you're in the torque curve. And that torque curve, that's, for most applications, that's the most important piece that you need to look at. And then there's also some marketing spin, if you will, that goes into play on a lot of torque curves when you look at brochures and typical sales type fodder. So there's different ratings on motors. We talked a little bit yesterday about most spindles will have a S1, S2, and a S3 rating, and will tell you how much torque any given spindle is able to put out. And that's a matter of heat in the motor. So you've got windings, you got current flowing through it. The more juice you run through that motor, the hotter it gets. So it will only run for a certain period of time at any given power curve, and then it's going to have to cool down and basically soften up a little bit, cool down before it can do it again. So a lot of marketing type material that you will see on the street, they'll advertise a 600 Newton meter spindle. Well, when you look at the curve, it's a S3 rating, which is a very small amount of time. Most of the time, the S3 rating is not long enough to really get into the cut very good. And then you drop down to an S2 rating, which is typically a percentage. For Okuma, we give it in a matter of time. So a 10-minute, a 15-minute, a 30-minute window of what an S2 rating is. Normally, that S2 rating is a long enough amount of time that you're getting machine processes done. And then you have your continuous torque, which is your S1 rating. So anytime you're judging and comparing machine tools, make sure you're looking at your S1 or S2 rating on your torque. The S3 looks great on brochures, but typically it's not a long enough period of time to actually do any real machining with.
So is that something you would be a little more concerned on turning machines or more on milling?
For me, more on milling. We see that a lot more on milling.
Okay.
Yes. S3 ratings on a lot of publications is such a very short window. When you overlay different companies' torque curves and you look at continuous and continuous and S2, the intermittent power, those are your curves that really is what you need to do the type of work that you're actually shipping out of your doors.
So when you rate this machine as 30 horsepower.
So 30 horsepower, that's at your top RPM, and then that's a continuous rating. So we have 199 Newton meter torque. So for the S2, and I think it's 15 minutes. I don't have my torque curve in front of me.
We won't hold you to anything.
Yeah, but I think it's around 15 minutes. So for 15 minutes, you can get 199 Newton meters of torque or 30 horsepower if you're up at the top RPM. When you go to continuous, that one I think is 149 Newton meters. So you drop a little bit for a continuous torque, and then same with the RPM.
Well, I don't want to let out too much of what's coming up behind this presentation, but one of the things that we were going to show, or are going to show, is an insert drill on this particular 40 taper machine, and I wanted to see how big of a drill we could push through here.
I love it. So I've been in this industry a long time. I've been running machines for 29 years now, and it's not very often I'll walk in and my jaw drops, but you you did that to me.
Good, and it was impressive, but it was actually, the drill wasn't so much of the problem as much torque that we needed. It was the twin cutters that we were trying to run after. And for years, we've always been, or I've always been looking at, okay, is it a geared head? What speed do I need to be? I always looked at the RPM to make the cut, because if you don't choose the right RPM based on the torque curve, it'll make or break the application. It'll just stall the machine, and they'll say, well, okay, we'll just keep reducing the depth of cut.
Right.
Actually, if you look at your torque curves, you might make it work. You just got to get your RPMs up, or down.
Or down,
depends,
right, depending
which
on
way it goes.
where you're at.
We see that, a boring operation is just like a turning operation. So it's a continuous torque drive, and we can make some fairly aggressive cuts. You just got to look at your torque.
And integral motors make a huge difference in that. So there's a difference in integral motors versus inline motors. So that's another thing to be aware of when you're looking at machine tools, is are you looking at a machine that's got an inline motor, meaning that it's a separate servo motor that usually is not cooled, and then that's coupled to the shaft of the bearing housing of the spindle, or is it truly an integral motor, meaning the motor itself is wrapped around the shaft of the spindle? The amount of torque and the length of time you get out of that is massively different than an inline spindle. So that's another thing to understand. There is a difference between inline versus integral.
But at the end of the day, I trust the engineers at the machine tool builders to make the right choices, and not put too many smoking mirrors out in front of me. So let's switch over from power to accuracy.
Yes.
Obviously,
that's a great conversation.
That's a tough one, because what kind of parts am I going to make? Are they going to be highest accuracy, or just?
I wish I had a part sitting here in front of me.
Unfortunately, I didn't bring one, but
I'll use this as an example.
Sure.
A lot of customers will come to us and say, "Hey, I make this widget. How accurate can your machine make this part?" That's a whole different conversation. I can tell you how accurate my machine is and what we expect out of it, But how accurate your part is, there's a lot of variables that go into actually making that part. What is your R&R and your work holding?
Yep.
It's disheartening how many customers we talk to, and we start getting into this accuracy conversation, and I'll say, what's your gauge R&R on your work holding? Deer in headlights. They have no clue. They've never measured it.
Yeah.
Well, if you need to hold 3 microns on your part, and I can dial a machine into that point, but your work holding is only good within 10 microns, you're never going to hold the tolerance you want to hold on that part. So the strategy on how we remove metal will make a difference on the tolerance that you're going to be able to hold on the part. So there's a lot of consideration that goes into how do we hold the part, what's our gauge R&R, what's the strategy of how we're removing metal, that are all considerations that goes into tolerance as well as the environment that the machine is in.
So the book values, the catalog values that I read online or from the marketing department, which ones do I gotta take with a grain of salt? Which ones are accurate and which ones are misrepresented? Which ones are...
That's a tough one to answer. So different builders advertise different ways. So speaking for Okuma, we advertise through an ISO 230 standard. So we can tell you that our
You knew an ISO standard.
I knew one. So I can tell you, this machine is a bidirectional. We measure it 5 times and we do all this. And then we do a Sigma, I think it's a Sigma 3. So we do a probability band. So when you look at our proposals or brochures, the accuracy that you're reading is basically a probability band that 99.7 will fall in.
The bell curve, yep.
That doesn't tell me how accurate I can make that part, right? So that's the frustration level sometimes that a guy like myself gets involved in. Other builders sometimes will advertise what the machine measured in one direction as the machine was being built. So 2 complete different, you're comparing apples to bananas at that point. So once you put way covers on the machine, you're adding friction and drag to it. Well, if you measure the machine with all that removed, it's going to look different than what it does when the machine is fully assembled. So we measure ours fully assembled as it would be on the floor. But even at that, and if you pick up the build sheet out of the back of this machine, it reads less than half of what the ISO standard is. So we build to less than the standard. So it gets complicated to be able to explain all that.
We see that too in the tooling where they get these certifications that it's this accurate, but it doesn't include anything on it. Right. They've taken all the pieces parts off and said, okay, it's good. But then when you assemble everything, wait, it's not quite there the way it should be.
So I will say all the top builders, and I won't name names because I don't work for them, but all the top builders, you put all the builders' names in a bag, you pluck a name out, you're going to have a good, solid, accurate machine tool. How we advertise, to me, some of that is semantics that you gotta work through and talk about what are you trying to accomplish on your part that you're trying to create, and how do we get there.
Well, looking on the inside of this, it's a beautiful looking machine too, because there's no exposed surfaces. So thermal stability, I guess, is a big concern, right? When you're talking to a customer, it's like, I want to know how accurate can I hold your machine to, but you look, okay, let's go look at your shop and where you want to put this first.
Right.
And if they show you the end of the corner and it's got a door next to it and a big punch press trying to run some other parts there, and they say, this will be where it's going to go.
You got really nice 3 inches of concrete that you're going to set the machine on.
Yeah, that much, huh?
Yeah, that much. That's a consideration. So Okuma, we do a lot with what we call thermo-friendly concepts. So all of our machines are designed with thermostability as one of the first considerations. So to your point, when you look inside any Okuma mill, you don't see cast iron. We line that entire enclosure with sheet metal, so hot chips, cold or hot coolant, none of that touches the base casting where all of our motion system is mounted to.
Sure.
So that's one area we engineer every heat source that we can out of the machine tool. So that's a consideration on.
But how much can the control software change that and adapt it to the problems or the environment, I'll say?
So that's pretty amazing. We have thermo rooms in Japan. We have multiple rooms in our facilities. When these machines are built, they go into these rooms and we map out the thermodynamics of the machine. So we run it through, I think it's negative 40 degrees to positive 40 degrees Celsius, and we map out everything that machine does as it goes through those temperature swings. So we have TAS, thermoactive stabilizer software. We have thermocouples embedded in the spindles and all the casting. And then every time that machine makes a rapid move, so it hits a G0, we know we're not in a cut. When it hits a G0, we can update the kinematics of the machine based on the heat and what we're seeing of the machine. And all that is mapped out. It's not just a math compensation where we say for every length of time, adjust this way. We do it from live sensors on the machine. And I can't tell you how other builders do it. I know most builders have some type of thermo stabilizer. How theirs works, I don't know. You'd have to run that past them, but I can tell you ours is measuring live and adjusting live.
So you touched on a point, and I'm going to segue a little bit here, but you mentioned sensors.
Yeah.
And with deliveries, kind of crucial right now. Orders are good. If you got a lot of sensors on this machine, are you able to keep up with delivery? Because sensors aren't so easy to come by right now.
So far, we're in pretty good shape, and part of that is due to our stocking program, the fact that we were able to bring in so many machines before that crunch happened. So, but it's definitely a concern that we're keeping on the horizon and forecast on what we do. Yeah.
Cool. So a couple other things that we still have to cover here before we come to the end.
How much time have we got?
We got a few minutes. So a couple of the other considerations that I like to ask customers are, what types of operations do you typically want to do with this machine when we're tooling it up?
Yeah.
And they say, well, we got to run one face mill and all the rest of this part, like an automotive parts, just a lot of spot drills, taps, and little end mills, but it doesn't have any real heavy cutting. And I asked them, well, what's your changeover time? Do you want collet systems or hydraulic systems? There's all kinds of varieties, shrink fit, whatever. When I'm looking at a machine tool, and I'm looking at whether I'm going to be drilling or tapping or milling only, do you tend to push somebody one way or another way?
Rephrase that to me. I don't know if I follow you.
If you were saying, well, most of this workpiece has got high precision boring, and I'm the customer and I'm saying, what would be the best equipment?
Different machine that you would
that says, well, no, I'm just going to be all heavy milling. No, it's all heavy end milling.
Yes.
Do you distinguish, or do different builders say, for that type of application, like tooling, we have different tool holders that work better for heavy rough milling versus light milling, it's adaptable.
So I'll tell you the gospel according to Wade, okay, for whatever that's worth. There's definitely different approaches. We have linear guide machines, the M560 behind us, that's a linear guide machine. We also build boxway machines. So for Akuma, our Millax series for mills are all boxway machines. All of our lathes are boxway machines until you get into multifunction. So part of that, typically a lathe, I like to talk about it in terms of like an aircraft. A lathe, you're taking a big heavy cut and you're going in one direction, generally speaking. So it's like you're loading everybody up on a 787 and you're flying to Germany or Japan. Then we have multifunction machines where you're doing typically more dynamic, fast movements. That's more like a fighter jet. You're doing fast, dynamic motion. Well, on that, do I want a boxway machine where you've got a lot of surface area contact? You've got stick slip that you got to overcome. So we built a phenomenal machine tool. We built our controls, our motors, our motion system and all that. We've got great control over the machine. But again, I think you mentioned it's the laws of physics. You have to overcome stiction in some way. We inject high pressure air and different things to elevate it, but you've got a lot more surface contact to overcome to do fast motion. So that's one consideration that I look at when I'm talking to customers. Another one that most people, or fewer people talk about is, what is your maintenance program? So you can have a boxway machine. I'm a fan of big, heavy machine tools. That's just ingrained in my blood. But those gibs are adjustable. You have to adjust them and you have to maintain them. So if you've got a boxway machine and a geared headstock and you're all proud that I've got this big, massive machine, but you don't maintain it for 2 or 3 years, and that surface wears and you haven't adjusted the gib, all the rigidity and strength that you thought you once had, you no longer have. And you'll notice you're not getting the cutting performance and you're getting more chatter and things like that. It's because you're not maintaining the machine tool. So a boxway machine has to be maintained. The gibs have to be maintained. If you've got turkite, a lot of times on big machines, you'll turkite those slides to give it less friction. That has to be maintained. A linear machine, you don't. No. So our MA600, we did a test cut against a machine with a big boxway geared spindle with our linear guide integral spindle, and we outperformed it. And some of that came into the engineering of the machine. We had a massive torque spindle, but our linear guides on that machine are massive when you look at it.
Right.
So we've got a lot of surface contact, even though it's a linear guide machine, because of the roller packs and the size. We're usually 1.5 to 2 times the size of anybody in that category. So there's trade-offs that you have to look at. But I look to the style of machining and then your maintenance program.
Sure.
So
cool. So we're getting close to the end here. We've got a few more things to talk about, but options. I'm gonna end it on the options, which I think is probably the one area that the customer can guide the path of what they want on the floor. Do they want the power steering or not? And you know, we see some of the options that aren't bought, and we kind of scratch our head. You know, 10 years ago it was like through spindle cooling, and we'd see machines delivered, and they wanted to do big diameter drilling or boring, and they didn't get the through spindle cooling option because it either didn't come with it or they didn't want to pay for it, and they'd get through it. That one always, we scratched our head because, you know, that's so critical. And now I see it more. You got high pressure coolant systems through the tool, but they won't get the tooling that supports that. You know, we've made incredible investments in the last 5 years on new ways to improve coolant delivery on the tool holder into the cut.
Right.
And they are a little bit more expensive because you got a lot more holes you got to put into the tool holder. You still got to do some balancing. So we see that, and it's like, okay, you've got this beautiful machine, this beautiful coolant delivery system with high pressure, but you're not using the hose to get it to the cut.
Right.
And we try to get them to understand the need of, you know, more coolant on the point of contact. It's got to be there. You can't just ask for it to come around and spray and expect the same result.
Yeah.
Are there any other options that you see that people don't utilize that they should? And it almost should be a standard if you had your way in Wade's world. Could I just make the standard on all the machines so that people wouldn't have this option to buy it? It should be there all the time.
Right. And high pressure coolant, that's a starting point. 1,000 PSI, as far as I'm concerned, should be standard. On mills especially, turning, you know, maybe not so much depending on the type of materials that you're cutting. When you're getting into mills, why would you not at least start at 1,000 PSI? We're seeing a lot of customers, as materials are getting more difficult to machine, you get into more of the Hastelloys, Waspaloys, you know, the Impossiloys. You know, we're seeing customers go above 3,000 PSI coolant. So it depends on the type of work that you're doing. But 1,000 PSI coolant with a lot of shower coolant, that's always a very big concern. Chip control is one of the most important aspects of machining. Whether you're machining titanium and you don't want to recut the chip, or if you're trying to put automation onto a machine, if you can't control the chip, you cannot automate the machine. And I think it goes without saying the world is going more and more automated. So being able to have that forethought to say, okay, right now my machine, I'm going to have an operator loading parts. 5 years down the road, that might not be the case.
Sure.
So are you setting yourself up in a way that you can add automation down the road if you need to? And to me, shower coolant, air blows, things like that, to be able to get into all the little nooks and crannies that could create a problem somewhere down the road. Everybody's machining process is a little bit different, so chips, I can walk up to 5 machines, all, you know, the same flavor of machine, but chips will be accumulated in different areas based on the geometry and the way that they're cutting. So being able to have that flexibility to adjust and control that's important.
So I guess you know the term, don't option me to death.
Yeah.
You know, it's you got the base machine and the price looks right, but at the end of the day, when you start adding up all the options, I mean, we see it with our tool presetters, we try to include as much on the standard equipment, the standard package, so that the customer, when they get it, is satisfied, and the add-ons were their choices. But I think the options, I've seen that with competitors, they like to take those out to keep the base price as low as possible, and then we'll just tack on the options, and it won't look so bad on the proposal. Do you agree or disagree with those types of strategies for sales?
So there's a 80-20 rule, I think. I feel good about bringing in a machine with a USA standard content that will hit about 80% of what people are looking for. Then the last 20%, that's usually more customer preference, right? So for us, most of our machines we bring in, we don't bring in standard with a chip conveyor. And the reason for that is if I'm doing a mix of materials, well, I want a twin belt drum filter conveyor. But if I'm a customer and all I'm doing is big, thick chips the size of my thumb, a standard hinge belt is fine. So that gives us some flexibility for the customer to dictate, you know, he can save a little money by going hinge belt if he doesn't need the filtering stuff.
Sure.
So, but a Big Plus spindle, you know, put a plug in there for you, Jack.
Well, I appreciate that, because
why would I ever bring a machine in without a Big Plus spindle?
Right.
You know, that to me is just such an easy standard that it doesn't make sense not to. So those are areas that spindle probes, things like that, that, you know, you're going to need it at some point. Why not go ahead and get it up front when you're buying the machine?
Well, our companies in Japan are very well aligned, and Big Plus has been a standard on Akumas for well over 10 years now, and that decision to grind them all to Big Plus was I think a real good strategy.
Yep.
And the proposals include Big Plus to the customer to understand that that's there for them to take advantage of it. And a lot of people don't understand that Big Plus might be there. It's your choice to use it or not use it. And if you are going to use it, go with the premium quality dual contact systems. It's got a lot of tolerance in there to make this work.
Right.
And if you don't use the right tooling on a Big Plus spindle and you want that dual contact, it could be tragic.
Yeah.
In the end.
And we've seen it. Unfortunately, we've had experiences where we have a customer in the field calls in, I'm using dual contact taper tooling, but I've got fretting in the spindle. As soon as you hear that, I can pretty much guarantee you take that tool holder out and measure it, it won't measure to the standard. And what's happening is you're getting face contact and not taper contact.
Yep.
And that's floating inside that taper.
Yep.
So it's important that you get the right spec for the right spindle.
And that's what I recommend. If you're going to do it right. If you're not going to do it or you don't want to afford it, then stay away from it.
Just make sure you
stay
got that
with
taper.
A standard Cat 40.
Yeah.
So Wade, we're starting to run out of time, I think. And,
I get long-winded.
But I am so proud that you could say your first call or first visit out of the office or home office was to come visit us here in Chicago.
Yep.
And we
It's great to be
are
here.
now a proud Think partner. And we would like to encourage all of your customers to look at what Big Kaiser is and what we can do for them now and in the future, or in what we've done in the past. Think Partners, I think, is a great model for bringing two technologies together.
Right.
And to make the customer aware of what the best options are. So it is a system, and there's a lot of moving parts in this, and it's not just the machine, the control, or the tools. The work holding plays into that, and of course, I think shop personnel.
I agree.
At the end of the day, when I'm selecting a piece of equipment, I would probably go to my shop personnel, bring them in as a group, and say, okay, we've got these three options of equipment. What do you all suggest? What are your suggestions or comfort levels? What do you know about these that you would say, I just don't like that, or I'd love this one, and tell us a little bit about it. So I like the team approach on buying, but I understand sometimes stock wins it all.
Right. Yep. At times.
But thanks for coming, Wade.
It's great to be here. This is I'm like a kid in a candy store. You know, this place is fantastic. You've got everything from automation components to work holding to tooling. It's kind of a one-stop shop for that type of industry. So.
Well, you're all welcome to come here at any time. The showroom is always open, and we're available to answer any questions. So if there's nothing else to do at this point, I'm going to turn us off and wish you a good trip back home to North Carolina.
Good. Thanks, Jack.
Take care, Wade.